Okay, let's do number 11 now. Again, the distance formula. So the distance is going to equal, my 2 points on this one is 21 and 5, 28 and -1. Okay, so the square root of 21 minus 28 quantity squared plus, since I started with 21, I have to start with 5 minus a -1 squared. So here I get -7. Notice I put that in parentheses. Again, it's important. Plus, minus a negative is plus a positive. So 6 squared. So I get 49 plus 36, which happens to equal 85. So the answer then is distance is going to equal the square root of 85. All right, that was number 11. All right, let's go ahead and move on here to number 12, where the point is 0, -5, and 18, -10. Okay, again, distance formula is going to equal x minus x, so 0 minus 18, quantity squared, plus -5 minus a -10, quantity squared. So here I'm going to get -18, again in parentheses, quantity squared, plus, minus a negative is plus a positive, thus that's just going to be 5 squared. Now, -18 squared happens to be 324, plus 5 squared, which happens to be 25, which gives me an answer of the square root of 349. Okay, so the distance then equals the square root of 349. All right, so that's number 12. So I'm going to move that one out the way, and let's look at number 13. The measure of angle x is 18 more than 3 times the measure of its complement. Find the measure of x. Okay, so let's do this. If I have an angle x, its complement is going to be 90 minus angle x. Right? Because if I add them two together, they'll equal 90. So if you know one of them, you subtract one of them, and you'll get the other one. All right. So if angle x happens to be 18 more than 3 times its complement, that means if I subtract 18 from 3 times its complement, then that will be equal to angle x. All right. So let's go ahead and work this out. So I have x equals 270 minus 3 times angle x. And then this is minus 18. So if I add 3x to both sides, I get 4x equals. Now, 270 minus 18 is 252. And now I just divide both sides by 4. I get x equals 63. So if the angle is 63, then its complement angle would have to be 27. But look what the instructions say. Find the measure of angle x. So angle x is 63 degrees. Okay, let's go ahead and move that out the way. Let's make this a little bit bigger and look at number 14. It says, find the value of x that will make lines A and B perpendicular. Well, we know if lines A and B are perpendicular, then this together would have to be a right angle because it would have to form 90-degree angle, correct? All right, with that being said, let's go ahead and take those two angles, add them together, and set it equal to 90. So 3x plus 4 plus 4x plus 2. If I add both those angles, it should equal 90 degrees. So I get 7x plus 6 equals 90 degrees. Subtract 6 from both sides. I get 7x equals 84. Divide both sides by 7. I get x equals 12. So let's find out what they're asking for again. Find the value of x that will make A and B perpendicular. Well, then x then would have to equal 12. And that would be number 14. Let's go ahead and do one more on this one. So let's go ahead and shrink that out. Let's move this down here so I can look at number 15. And move this way up here. Okay, let's look at number 15 now. Name the vertex of angle 3. Now, the vertex of angle 3. Angle 3 happens to be the angle GCF, right? GCF would be angle 3. The vertex is always in the middle, right? So C would be the vertex of angle 3. Let's go ahead and do a couple more because these are really easy. Name the sides of angle 1. Well, angle 1 happens to be right here and right here. So we're just going to name those two sides. Well, we have ray GH. That would be a side. And then ray GC. See, there's GH and there's GC. And that makes up angle 1. All right, let's look at number 17. Number 17 says, write another name for angle 6. Well, let's go ahead and erase this over here and look for angle 6. Now here we're going to write another name. Here's angle 6, this angle right here. Okay, so we start up here. We got a C, an F, and an E. So angle 6 could be written angle CFE. Let's go ahead and do number 18. Just go ahead and finish this off over here. Name a pair of angles that share exactly 1 point. A pair of angles that share exactly 1 point. Now, they couldn't be adjacent because all these other ones would share 2 points then. You'd have the point of vertex and then the point on the side they share. So let's go ahead and name two angles that share only 1 point. How about angle 7? Now there's more than one answer to this. Oops. There's more than one answer to this. How about angle 7, which shares the point C with, C with angle BCD. Oh, I don't even no idea why I just wrote all that. I meant to say angle 7 with angle BCD. Oh, there we go. If you look at both of those, these share this common point C. Because angle 7 is the angle ACG. Notice they share the same vertex, angle C.